All right, well, welcome. Thanks for taking the time to do a little bit of study. We'll take a look at the first few questions here in this video, and so off we go. Let's see how we can do here. So this first question, it doesn't actually look exactly like the one in the test. You know, I don't want to be too direct. It is a college class and all, but in this case, I'm asking you literally to find all of the versions of these equations. And on the test, it may be like which one does a certain thing and find that one, kind of like in the first test. But we want to see what the pattern is that exists in all of these values. So you're going to notice in this one, I noticed that C in this particular case seems to grow by 1 quite consistently. But as you look down here, I don't see a constant addition. It went up by 4, then it went up by 12. So that's not the pattern. So, but I do notice that this is actually multiplying by 3 as you proceed along. And so the kind of function that comes about through repeated multiplication is an exponential function. So I'm going to write down that it's an exponential, and the form of an exponential function looks like y equals a times b to the x. And remember that common value that is being multiplied is 3. And instead of using the letter x, I'm going to use the letter c because that is the independent variable. And instead of using the letter y, I'm going to say d. And last but not least, this A value is the initial condition. And sometimes you have to go earn that. But in this case, I handed it to you right here. So we've got that. When you look at the second problem, what you might notice is these quote unquote X values are growing by 2 as you work your way across, but the Y values are growing by 3. So if we think about delta Y over delta X, meaning our slope, we'd be looking at a slope of 3/2. Now, in the first test, some of you kept saying it's upside down. You got to be careful. Remember, it's rise over run. You want to think of this as the independent variable. This is the dependent variable, like as in the X's and the Y's. And so we're good to go. So remember, you would like to, if you can, write it as a simple mx plus b. And unlike this one, where the initial condition is here, in this one, the initial condition is actually right there. So it looks like my intercept is -1, my slope is 3/2. But just like before, instead of using the letter x and y, I'm going to use n in place of the letter x, and I'm going to use r in place of the other one. Now, of course, it's always smart if you're doing something like this to double check your values. So notice I'm going to take the letter n right here as maybe 6. And if I plug in 6, I'm supposed to get 8. So let's just see. Is that true? Well, 3 times 6 is 18. 18 divided by 2 is 9. And that appears to check. And in the same way, we might want to go back to this problem right here and try a number like, say, plug in 2 and give me 18. So if I plugged in 18 for D and I plugged in 2 for C, we can see that that also works because 2 times 9 is in fact 18. So one last one of those. So what I notice in this particular case is it appears that as we're going down, we're dividing by 2, but in an exponential story, we want to really think of that as multiplying by 1/2. So again, we could start with some kind of an exponential story. Again, I didn't write the word linear, but I should. This is exponential. So some kind of an a times b to the x. Initial condition here being 120. My constant multiplier here is 1/2. And that is raised to the, I guess instead of saying X, I'm going to use the letter R. And instead of using the letter Y, I'm going to use the letter B because that's how that particular story is phrased. Okay, now you could also say that B is 120 times 2 raised to the negative R because that's equivalent. Remember, a negative exponent is reciprocal, which is what we have there. So for question number 2, section 2 is going to talk about how this thing plays out. So keep in mind, we said we don't ever want to have anything attached directly to X. So I'm going to go ahead and do a little teeny bit of simplification here of F. If I was looking through this particular problem, I would call the parent function the square root of x. That would be what I would call effectively g of x. And so my first transformation is right here. This is the one that I would notice is that I would reflect across the x-axis. Now, again, some of you guys would choose to do this a little bit differently, and that's okay, but I'm just being very, very thorough. The first thing that's going to happen is it's going to flip it upside down. The second transformation I would probably pick would be this guy right here, and hopefully these colors look a little bit different. They actually look pretty similar on there. But the second one is the fact that it got multiplied by 3 right there. That is a vertical stretch. In other words, we're going to multiply y values by 2. So it got taller. Now, the third transformation that I see comes into the inside. This piece right here is going to be a case of dividing the x values by 2. But technically what that means is actually it's like a horizontal contraction. The fourth transformation that I see is going to be right here, this -5, which looks like we are actually shifting to the right 5. So it's a horizontal shift, which means go to the right 5 units. And last, my final piece right here, the fifth and final transformation is a vertical shift. Now, the fact is, and that's going to go up 4. So just to kind of work our way through it, if we were, say, taking a point on the original curve right here, like let's say we had 16, 4. As we go through this, the first thing I would do is I'd reflect it across the x-axis, which makes it 16, -4. Then what's going to happen is we're going to do a vertical stretch, which means we're going to multiply those y values by 2. So it became 16, -8. Then I'm going to horizontally contract, means I'm going to divide all the x values by 2, and now it's going to be 8, -8. I'm going to do a horizontal shift, which means I'm going to move the x values to the right 5, which became 13, -8. And finally, we're going to go up 4 units, and that's going to make it 13, -4 should be my final answer that does this. Now, again, what I do want you to realize is that you could have reordered these in some way, and so I'm going to write this in kind of a strange way. I'm going to call this phase 1 right here as reflecting over the x-axis. I'm going to actually call this one also a phase 1. Now, this is a phase 2. I got to be careful about this, how I want to do this. This has to be first. This one is first. This one also is going to be considered a first. This is a second tier. In other words, you have to do these before you do this one. And similarly, this is a first tier and a second tier. You must do this one before that one. But you can do any of the ones first and any of the twos second. But that's just kind of how those things play out. That seems a little bit strange, but hopefully that's going to be all right. Now, let's go ahead and look at number 3 and 4, and we'll kind of be done with this at that moment for this particular video. Let's see if I can get this thing to focus in. So the first thing I want to do is if I want to take this strange little question right here, this is f, and I want to reflect it across the x-axis. Well, if I want to reflect it across the x-axis, I put a negative out in front, the opposite of that f of x. Well, remember, f of x is this entire thing right here. So in other words, that's actually it. I'm actually already done. But if I want to reflect it across the y-axis, That's a little bit different. I'm going to take f of negative x. So I'm going to take the original function, and wherever I used to see an x, I'm going to replace it with a negative x. That's the right answer. Now, again, if you wanted to, we could write it, I believe, a little bit better by taking that x out and writing it this way. That's a stronger answer. But the key to these questions is to write them in this way first. If we wanted to stretch the thing horizontally by a factor of 3, that means I need to replace all the x's with a 1/3 x. So I'm going to have f of 1/3 x would be 2 times the square root of 1/3 x plus 3. So notice that I just replaced the x with 1/3 x. Again, don't leave anything attached to x, so it would actually be nicer if we could rewrite it that way. And last, if you're going to reflect something across the y-axis and go to the left 2 units, that's one less little piece, but I'm going to reflect it across the y-axis and go to the left 2 units. It's going to look like this. So I'm going to find the function, which is 2 parentheses, all of that stuff with the 3. I'm going to replace what will used to be x with a negative parentheses x plus 2. Now, this is a valid answer, but it would be really nice to clean it up ever so slightly. And so I have 2. I've got a negative x minus 2 with a plus 3. Or in other words, negative x plus 1. So my final answer would be like this, and this would again be the preferable answer in each case. Okay, so hopefully that works pretty well. And then our last little thing is if we're doing this thing, we're going to find the coordinate of what would happen. So we're going to take this one little piece at a time. So for starters, we want to remember that anything on the inside here affects x. Anything on the inside is x. Inside is x. Remember, outside is going to be y. That green kind of covered those up a little bit more than I wanted to. So in this case, the x value is going to do the opposite of what it says. So I'm going to add 2 to it. And then the outside does exactly what it says to the y value. So it's going to multiply by 5. This one, we want to factor out that 1/2 because we never let anything be attached to x. In fact, nothing is happening at all to the y value, so I can leave it alone. But according to this, I'm going to, instead of cutting it in half, I'm going to double it. So 4 doubled became 8, then slide to the left 4, and it became back to 4, which ironically was where we started from. And our last problem for this particular video, again, we're going to go ahead and factor out that negative 3, leaving x minus 4. Remember, if you distribute, you get a negative 3x, which we have, and negative 3 times negative 4 is 12. So we're good. So the only thing that has happened to the y value right here is this negative 3 is going to get multiplied by negative 1. Remember, the outside values affect y in exactly the way that they say. And on the inside, we're going to affect x in opposite land. So instead of multiplying by negative 3, I'm going to divide by negative 3, which gives me negative 5, right? Positive 15 over negative 3. And then we're going to add 4 to that, and I got negative 1. And so that, I think, should summarize the first 3 major questions or 4 questions pretty well. And hey, I will see you back in class for another session on some of those problems at a later moment. Okay, good luck. Thank you very much. I'll see you back in class.